Hello, so today I want to talk about some stuff I think is interesting, and that I would call what should I call? I will call this algebra of rotations. What I mean by that, I will come about it. So let us say we have a three-dimensional space and three orthogonal axes x, y, and z. And as we know, the rotation about the z-axis by some angle is let me say let me call gamma half the z axis. The matrix is represented something like this. So it will be so this is just as it is. So it will be here cos gamma, cos gamma, sin gamma, minus sin gamma, and finally cos gamma. And you can do the same thing for rotation about the x and y. So let's say alpha rotation about the x, and I can write this as so this will be unchanged, and it's cos alpha, sin alpha, minus sin alpha, cos alpha. And finally you have the last rotation, which is this. So you have so here I have to be careful. Here it is cos alpha, then minus sin alpha. Okay, sorry, beta. Let me say beta about the y-axis, right? Yeah, about the y-axis. So beta. So beta here as well. Beta minus sin beta, cos beta, sin beta. Why did I say write this now? I will tell. So if you suppose you have a very small rotation in the x direction, a very small rotation. Let's say what should I write? What should I use? Let me use theta delta of x. A very small rotation about the x orientation. So this is so this will be equal to as it will be something like this, right? 1 0 0 0 0 cos of delta, cos of that small angle about the delta axis, sine of that small angle about the delta axis. uh, my delta and gamma look a little, it's hard to, okay, so delta delta, same thing I will do here, minus sine of delta x, cos of delta x. And now I will also rotate about y axis, rotate about y axis with some small angle delta. So this will be this, right? So this will be cos of delta y minus sine of delta y, cos of delta y, okay, sine of delta y, and cos of delta y. Let me also write down for the z now, because let's just write a small angle displacement in the z direction. So it will be, I didn't have to do that, I could have just assumed that alpha beta gamma are small. This was unnecessary, fine, but I have started. So now I will just write again small angle, small delta angle. A very small angle. About the y-axis. Very small angle. Now very small rotation about the x-axis. We are doing z-axis. Cos of delta z, sine of delta z, minus sine of delta z, cos of delta z. Now these angles are so small, I can use an approximation that they are almost equal to this, because it is very true, like for very small angles cos almost behaves like 1 and sine almost behaves like angle itself minus delta of x, and this is a delta of x, and I will do the same thing here. This is almost same as, almost I would say, like there will be some higher order terms, some higher order terms will be there. So this will be 1 1 1, and now here it will be delta of y minus delta of y and some higher order terms, and finally this will be 1 0 0 0 0 1 1 minus delta of z plus higher order of delta of z square, right? So we have these things, and why I said was rotations are not commutative in general. What I mean is, if you have a body, if you first rotate it about the x-axis, then about the y-axis, it is not the same as rotating first about the y-axis then about the x-axis. Both will give you completely different orientations. But when you do it for a very small angles, very small angles about this, then for small angles rotation is almost commutative. Like for small angles, these two almost become equal. So if that's the case, let us see what happens first. Now you will say, why not? So these both will just cancel each other for small rotations. I don't want that to happen. Okay, let us not take this assumption for small rotation almost. Let's see what happens. So when I first just remember that in general they are not commutative for any angle. Let us leave the small approximation here. So now when I first do about the x-axis, then about the y-axis, what I am supposed to be getting is, let me do the matrix multiplication here. So first about the x and about the y. So what I would get is, I would get a 1 here, and all zeros, and then a 0 here, and I will get 1 minus delta x squared. Oh yeah, 1 minus delta x squared, and then 1 minus delta x. So 1 minus delta x squared, then I think I messed it up, did I? I think I wrote it wrong here. Minus 2 delta of x. Here it will be minus 2 delta of x. Wait, that is x and y, right? Okay, I may be doing very terribly wrong here. My brain is not working anymore. Sorry for that. Minus delta y delta x delta y. I hope this is correct now. Mm, I suppose it is correct. Here it would be a 1, and then here it would give me minus of delta x, I suppose. Mm, Minus of delta y. It's very difficult to write. Delta of x, and finally it will be a 1. And then ry rz, let's see the other way around. Rx, what if I do this? So this will be equal to, so if I do that I would again get a 1. And then I would get delta x delta y, right? I am taking this and multiplying it on this. I am applying this on this. Mm, then it would be delta of y, then I don't know where I am going with this. It's very difficult, honestly. And then it would be 1 again, and then minus delta x, and then minus delta y, and then I don't know where we are going. Delta x again, and then finally 1. Hmm. So when I subtract this, I would get, so if I take the difference of this, I would approximately get, not approximately, equality, but this equality is of approximations. Uh, I think there is no, I mean there are two zeros here, so I don't know why there is one zero, but let me recheck. It shouldn't be the case. 0 1 0 0, yeah, it's perfect. But what happened here? 0 1. So let me just do it in maxima and check. I want the result at this point. So let me define a rotation in x direction with small angle a, let's say. I will just skip this part. I will just write the code. Okay, I made the code for this is rotation in x and rotation in y. Let me check if I did calculations right. So when I do x first and y first and x later, I will get something like this. Okay, I had done apparently a mistake. There was not supposed to be two zeros here. I don't know what wrong I did. Okay, there will be a delta y here. That was a mistake. Let me write it in red. So, so everything else apart from that looks correct. X, y, 1 minus x. Yeah. So let me check yx. X, y 0 minus x. Yeah, let's now let's take the difference. X, y minus y x, and I will get something like this. Yeah, I just took the difference. So when I take the difference, this is something like this, 0 0 everywhere except at two locations. So it's minus delta x minus delta x delta y minus delta x delta y, right? Okay, it's a minus plus here. Let me check. If I do the subtraction, hmm, did I do a mistake again? uh, xy minus yx, right? Xy was this. Here everything makes sense. We were again arithmetic mistake I did, I guess. Xy yx. Now, hmm, okay, again an arithmetic error. Minus times minus becomes plus. Fine. This is a plus here. No minus sign. Then it will be this. So notice here, this is nothing but so this is actually 1 1 1 minus delta x 0 0 0 0 0 minus identity. So when you rotate about x axis first and y for small angles, please remember this, and then do the other way around. For y, x and y, this is approximately equal as, for small angles, doing a rotation uh, of product of the angles So basically you did an angle x here, an angle of y, small angle of x, small angle of y. This is approximately equal to doing this. And this is I don't know what to make up of this, and this is somehow, and this is actually in short form written like this: commutator of rotation operator in x for tiny rotations with commutator of y is equal to, for small rotations only, this is almost equal to rotation about the z axis. Okay, I want to write in more compact form. Let me use this notation. Angle will be written on top of the alphabet. So rotation of x, rotation of y. This is same as rotation of x, rotation of y minus times identity. There is this structure here, and this is later used a lot. Uh, this thing, this very fact that happens in our normal Cartesian 3D space, which we are the most familiar with. At least I am the most familiar with. So this has consequences, apparently. I don't know what exactly are they, but they do have consequences. Hmm. Oh, also I did this wrong. It is supposed to be here. Sorry for that again. Hmm. I did a mistake. Let me fix it. So here we go. So what am I doing? More. So here we go. This is the right one. So I hope I didn't do any arithmetic error now. I often do that. Delta y. Hmm. Something similar was written in JJ Sakure, and let's check that. So you can see it is written. Same thing. Why? I really don't know. Like, what is significance of this? I wish I knew, but I don't have any idea what it means. Someday maybe I will understand, and I will try to make a better explanation of this. But so far, this is all I know. You do a small rotation about two orthogonal axes, and that is almost equivalent to taking a rotation about the third orthogonal axis, of course in only 3D, and subtracting it by the identity. Really, I have zero idea what this means. That's it for today. Thank you for watching.